Hi, welcome to alert-whatif, the Grafana plugin. My name is David. Today, let's bring a Grafana alert to life, simulate the data, compute it bit for bit, and visualize the whole thing. We'll follow a single alert, one that's watching a receipt printer, and ask 4 questions. First, when the printer goes down, how long until the alert fires? Second, the printer's struggling, so why is there still no alert? Third, the printer's fixed, so why is the alert still firing? Fourth, when it fires, does the email actually reach you 1, none, or 50? This video answers the first. Let's get started. First, what are we watching? A receipt printer in a store. An order comes in. We queue it as a receipt to be printed, and the printer prints it. But if the printer gets stuck, the jobs pile up, and the oldest one's weight just keeps climbing. We track that weight as a metric queue lag, the age, in seconds, of the oldest queue job. So we put one Grafana alert on it, and here are the few parameters we'll use, straight from the real config. A is the query, the promql, that gives us one number, the max lag. C is the threshold crossed 60 seconds, and it counts as breached. To the alert, queue, lag, isn't a smooth line, it arrives as samples. Recorded at a regular interval, they build a time series. The lag climbs continuously, but the alert never watches in between. It checks the data tick by tick. We've got the rule, and the data the alert runs on. So the real question is how long it actually takes to fire. Let's measure it. Now, let's start the first case. We will mock push a printer queue lag metric value exactly 1 second after the evaluation tick point, and then calculate how long it takes for the alert to fire. First, let's lay out the timeline. Grafana evaluates on the 10-second mark, once every minute. Now, a quick question. The lag starts climbing at 22:04:11, and by 22:05:12, it crosses the threshold 61 seconds, over 6, and we have a 1 minute 4. So when does the alert actually fire? Pause the video and take a guess. Let's trace it on the timeline first, then come back and answer. Now let's walk it, tick by tick, and find the answer. At T0, we begin simulating the printer's lag as healthy, starting from 0 seconds of lag. So at T1, just past an evaluation point, we start the lag climbing 1 per second. By the next minute, at T2, the lag passes the threshold, the lag value is 61 seconds, but we've only just missed the evaluation point. Until the next evaluation point, T3, that's when it enters pending. And at T4, it fires, after holding 60 seconds pending, kicking off the email to on-call. So here's the answer from the printer going down to the alert, firing, 2 minutes and 59 seconds. That's T4 minus T1, from the printer's lag starting all the way to firing. And it's 3 parts added up. The climb to the threshold, 61 seconds, the wait for the next evaluation tick, 58 seconds, and the 4 hold a full 60. 61 plus 58 plus 60, 259. For the demo, I'm using the alert-whatif plugin to visualize the state and the calculations. The main chart shows the metric climbing against the threshold, with the state underneath normal, pending, firing. Bottom left is the Grafana config change the threshold, the for, or the interval, and the states and the curve update with it. And bottom right is the compute trace, for each tick, the query, the threshold check, and the result. In the bottom right corner, we can simulate pushing metrics data to Prometheus, combined with Grafana's alert configuration to trigger the state updates. This screen recording quickly shows the process of case 0. By pushing data to Prometheus, Grafana uses these data plus the alert config parameters to calculate the status at each tick, and alert-whatif computes the same thing in parallel. Now let's walk it tick by tick. At T1, right after the jobbing queues, the lag is still near 0. The compute trace checks it against the 60-second threshold. It fails, so the state stays normal. At T2, a minute later, the lag crosses 60, but the alert doesn't catch it yet. The check just ran a second too early, so the state stays normal until the next evaluation. At T3, the next evaluation, the lag is well past 60, so the threshold check finally passes and the for gate flips the state to pending. At T4, 1 minute of pending later, it fires and the email goes out to on-call. That's the whole case 0 T4 minus T1, exactly 2 minutes 59. We just saw the case 0, the lag crossed 1 second after Grafana checked, so it missed and waited almost a minute. That's the 2:59. Now let's flip it. Case 1 is the mirror image. We pushed the lag 1 second before the evaluation tick instead of after same stuck job, same rule, only the timing flips. So the crossing gets caught almost right away, about 2 minutes and 1 second. Let's run it and measure. Same timeline. Now case 1. Grafana still checks once a minute, on the 10-second mark. At T0, the printer's lag is healthy 0. At T1, we start the lag climbing from 0 1 second before an evaluation tick this time, instead of after. At 2, a minute later, the lag passes 60, and it crosses just before the next check. So at T3, the very next check catches it right away. It goes pending almost immediately, no wasted minute. At T4, after holding 1 minute, it fires and sends the email. T4 minus T1 is 2 minutes and 1 second, almost a minute faster than case 0, just because the timing flipped. Here's case 1 the same run, but this time the lag crosses the threshold 1 second before Grafana checks. Right after the jobbing queues, the lag is still near 0 normal, and the check fails. But this time the very next check catches it, the lag is just past 60, it passes, and it goes straight to pending, no wasted minute. 1 minute of pending later, it fires about 2 minutes and 1 second, almost a full minute faster than case 0. So your detection latency isn't one number, it's a range. The reason is simple. Grafana checks at discrete evaluation points, not continuously. So, after your data crosses, it waits for the next evaluation point to be detected, and that wait is always more than 0, but less than 1 full evaluation interval. That's why it's a range. In the next video, part 2, the printer's struggling, So why is there still no alert? And once it's fixed, why is it still firing? See you there. So measure it, replay your own rule in alert-whatif, and see exactly where it lands. Links below. Thanks for watching.